It's a new day on SpaceX Daily, episode 41, coming to you from Vancouver. It's July 22nd, 2026. Plenty moving across Starship, Falcon, and Starlink today. Northrop Grumman's MRV-1 servicer is now on orbit after its Falcon 9 ride, beginning the first on-orbit installation of propulsion pods that could extend the life of 3 aging commercial satellites. SpaceX has slipped Starship Flight 13 by 1 day, now targeting a July 23 liftoff from Starbase. The vehicle completed its pre-flight checks after an earlier scrub, keeping the test objectives for booster catch and ship re-entry intact. This continues the flight test campaign that last flew in June, with observers tracking whether the new date allows the full set of orbital refueling demonstrations to stay on the original timeline. The slip follows the pattern of prior test flights where last-minute data reviews have protected the core hardware objectives without altering the overall campaign arc. While Starship pushes the frontier of heavy lift reusability, today's Falcon 9 flight shows the same reuse logic already operating at scale on a different mission. A Falcon 9 lifted off from Space Launch Complex 40 at Cape Canaveral, carrying Northrop Grumman's MRV-1 robotic servicer. The previously flown booster performed a nominal ascent and returned for a landing at the designated Cape Zone. The mission will demonstrate installation of propulsion pods on 3 geostationary satellites to extend their operational life using robotic arms and a docking system developed under a DARPA program. The Falcon 9 placed the MRV-1 into a super-synchronous transfer orbit that will take it to geostationary altitude while minimizing the servicer's own propellant use. Ground teams confirmed initial acquisition of signal shortly after separation and are now performing early checkout of the robotic systems before the long transfer to GEO. This marks the first commercial attempt at on-orbit satellite life extension using external hardware, with data from the first 3 installations expected to inform whether the approach scales to additional operators. Photographers captured the Falcon 9 ascent and booster landing at Landing Zone 1. The images show the payload fairing separation sequence and the first stage return burn. Public release of these photos provides the first visual record of the MRV-1 stack configuration. The sequence documents the fairing halves separating cleanly at the planned altitude. Live coverage confirmed nominal performance through max Q and stage separation. The booster returned to the Cape landing zone while the upper stage continued to the target orbit. Early telemetry indicated the MRV-1 had begun its commissioning sequence. The payload fairing protected the MRV-1 during ascent through the dense atmosphere. Post-separation, the servicer deployed its solar arrays and began attitude control checks. Early ground station passes verified that the arrays had locked onto the sunline as planned. The mission demonstrates how existing launch vehicles can support a new class of in-space infrastructure. The second stage performed a single burn to place MRV-1 on its correct trajectory. Telemetry showed nominal performance through the coast phase prior to the final insertion burn. The same first principles logic that makes this servicing approach attractive is unpacked in today's engineering deep dive. Observers on X noted the clean separation of the MRV-1 from the Falcon 9 second stage and the prompt array deployment. Several accounts highlighted the mission's use of a previously flown booster as evidence of routine reuse operations, while independent trackers posted preliminary orbital elements showing the servicer on a standard geostationary transfer trajectory. One analyst pointed out that the DARPA heritage of the robotic system could accelerate future commercial servicing contracts if the first 3 pod installations succeed. From an engineering standpoint, the MRV-1 servicer introduces a new operational mode for geostationary satellites by shifting the mass budget away from propellant carried at launch. The dominant cost driver for GEO assets has been the mass of propellant carried at launch and the limited specific impulse of onboard chemical systems. By delivering a pod with electric thrusters after the satellite has already reached orbit, The mission moves the heavy lifting to on-orbit servicing hardware instead of the launch pad. This reduces the idiot index of the overall system because the expensive launch mass is now spent only once on the core satellite, while the life extension hardware rides a separate, lower-cost trajectory. The robotic docking and attachment sequence must solve the same relative motion and contact dynamics problems that Starship will face during orbital refueling, yet at a smaller scale and with lower energy. Success here would demonstrate that the same first principles approach of moving heavy lifting to orbit can be applied to existing satellite fleets. Next data points to watch are the actual propellant savings measured on the first 3 target satellites and the repeatability of the pod attachment mechanism under thermal and radiation conditions at GEO. The electric thruster pods also change the station keeping equation by trading chemical delta V for higher efficiency electric propulsion once attached, which directly extends the revenue generating lifetime of each host satellite, without requiring a new bus design. On the AI front, SpaceX will supply engineering data to train Grok's next model while avoiding any restricted material. The arrangement gives Grok access to proprietary hardware and operations data that competing AI labs cannot replicate, covering vehicle performance metrics and manufacturing parameters without crossing export control boundaries. SpaceX is positioned as a potential multi-billion-dollar customer for AI services to the Pentagon through its existing satellite and communications infrastructure, with Starlink and Starshield networks potentially serving as the data backbone for defense AI workloads focused on low-latency routing of sensor data. The data flows that will refine these servicing techniques are also feeding another part of the Musk ecosystem. Worth keeping an eye on, Ray Dalio stated he had advised Elon Musk against concentrating his personal capital in SpaceX and Mars-related efforts. The warning centers on the long timeline and technical risk of achieving routine Mars access. Dalio's comments come as SpaceX continues to fund both near-term launch operations and the Starship development program from the same corporate resources. Resolution would require either demonstrated progress on Mars architecture milestones or clearer separation of investor and founder capital allocation. And a quick market note, SPCX closed at $123.54, down 1.2% from the prior close, with the first earnings call date now announced. Before we go, the next data point to watch is whether the July 23 Starship window holds and delivers the first on-orbit refueling demo. That's the day at SpaceX. That's a wrap. SPCX is trading at $123.54, down 1.2%. If you're new here, subscribe, and this briefing finds you every day. I'm Patrick in Vancouver. Thanks for being here, and I'll see you tomorrow. And before you go, this show is part of the NERA Network, a family of daily podcasts on tech, science, and markets, each one a short, sharp briefing you can finish on the commute. If today earned its place in your feed, here's your next listen. OmniView, a balanced daily world news briefing that takes every side seriously. Find every show free at neranetwork.com. The age of AI puts real builders on the phone with an AI host. Apply at neranetwork.com/age-of-AI. Apply. This episode used AI voice synthesis of my voice. Editorial selection and analysis are my own.